Hi everyone, in this video we're gonna go over a problem called Modern Art from 2021 CCC competition. It's both in the junior division and senior division. It's a senior 2, so you should expect it to be a little bit trivial. So like it means you cannot solve it as pure brute force. It requires a little bit of thinking, but it shouldn't be too hard. Okay, let's get into the problem. So basically, I'm gonna explain this like maybe in a shorter way. So you are given a grid, and every grid cell is colored with black initially, and you can do some operation to the grid. So let's say you have a 3x3 grid. Initially, they are all black. B, 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 B. You can flip a column or a row, and each flip will make the entire column to be in another color. So if it's black, it will be gold. Because there's only two colors here, like only black and gold, only B and G. So if the current row is G, then it will just be black. Sorry, if not the current row, the current cell is a G, it will be black. So if you have something like B, G, B in a row or a column, it will be G, B, G. So each cell will just become its opposite. Yeah. So let's try to simulate, and what you gotta calculate, like what your algorithm gonna do is to figure out how many gold cell is remain after a number of operation. And yeah, let's try to simulate the sample input 1. The sample 2 is quite large, so I don't wanna like draw everything. It would be quite complicated. Okay, everything starts on black. And we know two operations here. Flip the first row, flip the first column. So R1, C1, let's keep it 0. Don't treat it as a grid. I'll just do that cell something. Yeah, okay. So flip the first row, it will be okay. G, oh, hold on. G, 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 B, 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 okay. And now let's flip the first column. G, oh sorry, B, G, 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 B, 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 B. And how many gold is remain? 1, 2, 3, 4. Okay, 4. And what's the output for sample input 1? 4. Okay, I mean, we understand the problem, right? Or most likely. And now let's try to solve the problem after we understand it. So the most obvious way, or the brute force way to solve this problem is to simulate all the queries, all the operations, and just do what it tells you. So if it tells you to flip the first row, you just mark everything the opposite color in your checkerboard or in your grid. I'm not sure about the wording. Yeah, just in your grid. Just mark everything in the opposite color. But you know, in CCC, it's like they won't give you full credit anything beyond S1 for like a really basic brute force solution. So you should actually try to solve it in a smart way or somewhat smart way. So if you understand the big-N notations, in let's try to calculate the, or even if you don't understand. So there's basically a cap of computation like a computer can do it within a certain time limit. It's generally in 1 second, your computer can do 5 times 10 to the power of 8 operation. Because as you can see, the time limit is 3. So basically, we can do 1.5 times 10 to the power of 9 operations. So it's basically anything beyond that number or close to that number isn't that safe to pass the grader. So yeah, just keep that in mind. For different competitions, you have like different time limits. For example, for CodeJam, it's like 10 seconds. Yeah, just it varies from contests. Okay, let's try to calculate the brute force time, worst case time complexity. So imagine there's like a grid 1 times 5 million, and so it will be something like that, very very long. And unfortunately, all your queries all flip the first row, not column. So every row will take 5 million operations. And what's the maximum number of operations? Which is 1 million. So essentially it will be 5 times 10 to the power of 6 times 10 to the power of 6, which is 1 million. And it will give you 5 times 10 to the power of 12. Also, in your last step, you gotta count in the number of ghost cells in the entire grid, which will be 5 million, the grid size. And in total, it's a pretty big number. It's definitely beyond 1.5 times 10 to the power of 9. So it's basically like you're more than 1,000 times slower than you should be. And so it basically means your program gonna run like 2 hours to generate an answer for a case. So just don't expect you get lucky. The grader's speed somehow got increased. Just don't expect it because that algorithm is just too slow. Now let's try to find some smart way to do this. So I would just say the observations I made. Okay, I don't even know if I can spell observation, something like that. Okay, observation 1 is for each column or row, it doesn't matter. If you flip it an even number of times, it's unchanged. If you flip all number of times, it changes. So, if you gave me the number of flip, like 9, 8, 9, 7, 7, 3, 1 for row 1, I'm gonna tell you the row 1 is flipped to the opposite color of itself. Not because I just simulate everything in my head, it's because I know this number is an odd number, and that's it. And that's how we determine if a row or column is flipped or not. You just imagine like if you have wait a sec. If you have an all black cell, so B B B. If you flip it once, it will be G G G G G. If you flip it twice, it will be B B B. If flip it, it just goes back to itself, and it will be G G G G G. So that's first flip, second flip, first, second, third. And yeah, and I don't think I need to draw you like 10,000 rows to like to convey this, because it's pretty obvious. Okay, let's try to make the second observation. The second observation is it doesn't matter the order you flip it. So if you have a grid, if you flip this row first, then this column, there's no difference between like flip this column first, then that row. So this observation just make us able to treat them separately, and I think it can make our life much easier. So you don't have to like if you flip this one. So if the query is like flip this row first, this row second, this row third, three times. Wait, thirdly? Wait, it's like okay. So it will be like row one, C2, R2, C2. So there's no difference between Z and C2, C2, and R2. So you can just count the frequency of each flip to a particular column or row. So you know the flip number of this column is even. It means it's not flip, and we can just basically ignore those. Yeah, and we can just like treat the flips for column or row like within themselves. You don't have to worry about like any chain effect, which is just impossible. And now let's try to move on to implementation of this problem. So of course you can just uh, keep track of like frequency of flip to each column or row, and in the end simulate everything. But there can be an easier way to implement this, and it's not hard to come up. So you just keep track of the frequency for each row or column. And for all rows, like row, perhaps we're gonna make a table. So row 1, row 2, row 3. And the number of times they flipped, maybe 2, 4, and 11. And we will realize only this row is flipped. So it will be gold. Yeah. And now let's move on to columns. So C1, C2, C3. And perhaps there will be like 3, 3, 3, all flipped. So from a column perspective, you will realize that if it's the cell in each column that is gold initially, if that column isn't flipped, is the number of rows that it's flipped. So the gold for the number of gold for each cell, for cells in a column equals to flipped row, and black for each in each column is unflipped row. Not gonna spell that. So you can just count the number of odd numbers in this table, and then we just tell you how many gold will appear in each column if you don't flip that column. But of course, if you flip it, then these two numbers will just switch. Simple as that. So if the column is like 3, it's odd number, it means that column is flipped. Then these two numbers just flip. So this become B and this become G. And that's how we're gonna do this. Okay, let's try to code this. Of course, I think there's a easier way to understand, like easier approach to understand, which is just to do this and just to simulate the checkerboard again. But this time we don't even need to create the board. We're just gonna do some math, and that's it. I don't even know if it's math because it's just addition. Not even subtraction. Probably do some mod. Yeah. Okay. So let's start coding this. Of course, we're gonna include those stuff. Include bits std cpp.h using namespace std. Oops, I've spelled it wrong. Let's go back it. include. Okay, so let's make some variables. You know, making variable is pretty fun. M, N, and Q. let's create an array to frequency vector, and they keep track of the number of times a column or grid is flipped. So let's call it fric row m and fric column. Oh wait, what is it? N. Okay. Now, wait, can I declare it in that way? Yeah. Okay. Let's scan in all the queries. So if it's a row flip, then we increase the frequency table of that row by 1. Oh, the way I name my variable is so random. So n equals to the name of whether it's like R or C. And GG is the number of flip. Sorry, it's the number of row, like whether it's first row or second row, like the number of row. Wait, that sounds weird. The row number, okay, the row number or column number. Yeah. Otherwise, it's column. Okay. Hold on. Wait, I think this is actually kind of bad because the indexing start from 1. Let's just GUG minus. And now let's keep let's try to let's try to count how many row is flipped. How int counter row count flipped row. Count how many row is flipped. Okay. So let's just go over the entire vector of fric row. Actually, I don't need to do that. I like writing in things like in one line. So if I mod 2 equals to 1, then it's flipped. So flipped with flipped cow. Oh, that's usicle PDSD. Usicle PDSD. Row, okay. Now cow. Okay. Plus. And that's how we do it. And then we're gonna try to check the columns. So we can do columns first and then row. It doesn't quite matter. And we also need to calculate the rows, the number of rows that is not flipped, which will be, we don't need to declare this variable, but make things more intuitive. Let's create unflipped row equals to n minus flipped. And unflipped is black, flipped is gold. I think it makes sense from my explanation made before. Okay, hold on, never mind, I don't even know what that means. Just try to, yeah, I hope you understand my notes. And now let's try to go over all the hold on, all the columns. And let's create a variable to store our total volume. I'm making it long just in case. Okay. So if I mod 2 equals to 1, then our unflipped cow is gold. result plus equals to unflipped cow and row. Okay. Otherwise, hold on. I think I can do it in one line. Else result plus equals to flipped. Okay, and in the end, we're just gonna output result. Hold on. Not gonna use inline. Not gonna use inline. Okay, let's run all. Okay, hold on, it's not working. It means I made a bug. Okay, let's try to debug. The first thing I'm gonna try to debug is this, because I didn't do it in like the Euro format. I'm not sure if it caused the bug. Okay, this is really weird. Okay. Did I mess up the row and columns? Okay, so 4 is row. And Q, right. Okay. I don't think I messed up. Hold on. 1 to n? Yeah, it looks right. Perhaps I should pause the video and try to debug on my own. Maybe I should just like write for loop with braces. Yeah. I don't know. Okay, I think I found a bug. I have to change it to char instead of int, which I think is quite weird because I saw you can just like it automatically change a char to like its ASCII thing, ASCII2 tables like the index, but I don't think it works in that way, which is quite sad. So yeah, and now let's try to run the sample again. And as you can see, they pass. Okay, let's delete those disgusting comments and try to submit it to the grader. I think the way I wrote those like for loops was right. And as you can see, it passes all the sample cases. So let me do some conclusion while I'm trying to make this code look shorter. So I think the key for this problem is just to make the observation of the flips. So which is if you flip it an even amount of time, it doesn't change. If it's odd amount of time, it will change. So even if you just make the observation and simulate the checkerboard, it will not get time limit exceeded. Yeah. And even if you just to simulate everything correctly, you will get certain partial scores, which is pretty generous, in my opinion. Okay. Yeah, that's about it. Thank you for watching. Just give me 1 second to make this code a little bit shorter. Okay, it looks good. Let's try to run on the local machine. Okay, passes. Now let's try to submit it here again. Oh, much shorter. Okay, did I? Oh, okay, okay. A seed. So thank you for watching. Bye.